My name is Shane Glass. I am the program manager for Google Cloud's public dataset program. With me, I have three really awesome co-speakers that will be coming up on stage here in a little bit to kind of tell you some of their stories. Before we begin, I just want to kind of roll through what we're talking about today. So the first thing will be the current status of the Cloud Public Datasets program. We'll talk about how public datasets can support your GIS analysis, so your geospatial analysis, and how they can help bring additional value to the data you already have in BigQuery. Of course, as I mentioned earlier, we have demos from each of our three co-speakers who will be kind of detailing how public datasets supports them and how they're working with public datasets to do their geospatial analysis. And then we'll talk about next steps, kind of some actionable items that y'all can take forward and go out and follow up on. So before we get started, if you have any questions on the content today, we invite you to use our Dory QA. For those of you who don't know, Dory QA is an app that we use internally at Google, and it helps us manage Q&A at scale because it gives everyone a chance to participate and ask questions, despite the fact that we only have 2 microphones for questions. You can try this today. Go into the next app, click on this session. That's DA208, and you'll be able to click the Dory Q&A link from there. In the app, you can submit questions. You can upvote or downvote stuff you like. We have a gracious moderator who it may or may not be my manager, and I may or may not compliment profusely throughout the Q&A, who will be helping us kind of moderate that process. So let's kind of start with an overview and an update of the program. So here's our mission statement for the program. It's to maximize the accessibility and usability of high-value, high-demand data sets through Google Cloud Platform. Now, I get the question a lot. Why does Google do this? Why host these data sets? It's a really complicated answer. The good scientific answer is, well, it depends. But despite the details and the specifics, these all kind of fit really nicely into 3 answers at a pretty general level, right? And the first answer is that this is a really natural extension of Google's core mission, which is to make the world's information universally accessible and usable. You see these 2 words in bold up here. These are taken directly from that mission, so they likely seem a little familiar. And this work helps us make the most critical public data sets in the world easily discoverable, easy to understand, and easy to use. And it's a pretty fundamental core of who we are as a company. So that's answer number 1. We're following Google's mission statement. Answer number 2 is this. The current paradigm for discovering and using data sets, public data sets, can be really arduous. I'm assuming that everyone in the room remembers the scientific method, or at least everyone remembers that at some point they learned about the scientific method once upon a time. Whichever it is, don't worry, I won't tell your middle school science teachers. Your secret's safe with me. But this is what I call the data science method. And it's a really broad, kind of generalized level that describes the paradigm for analyzing public data. You can see the steps listed there. If you need a break, like need a breather or a cup of coffee after reading these, I get it. It's a really, at times, unnecessarily painful process. And it involves a lot of things that aren't analyzing data, that aren't communicating the results and the insights that you got out of it. And so that's part of the reason we launched this program in 2016, is that we looked at this process and realized that it was unnecessarily complicated and painful. We realized that a large number of our users were doing the exact same work. They're accessing the exact same public data sets. They're uploading the exact same public data sets. They're doing the exact same cleaning, even though they're doing different work. And we realized, hey, we could make this process a little easier by taking on a significant chunk of it. Well, what if someone did this stuff? What if we did this stuff? We're all familiar with the oft-cited paradigm that a data scientist or an analyst spends about 80% of their time cleaning and preparing their data, and about 20% of the time actually analyzing it. But what if we could change that? What if we could flip that? What if we could get people closer to spending 80% of their time analyzing and visualizing and learning from their data, and only 20% of the time kind of preparing and cleaning data? And we would do it by doing these things. And that allows you to focus on these things. And these are the things that you do. That's what you should be spending your time on. And so that's the second reason we do this, is that it helps simplify workflows and life for our users. The third answer to this question of why we do this is that our users are fundamentally telling us that this is important. This recent Gartner report from December of last year says that by 2022, 50% of cloud buying decisions will be based on the data assets provided by cloud service providers rather than on product capabilities. That's incredible. I mean, that is a massive shift in the way we understand how people choose their cloud today. In this same report, Gartner specifically identifies this program as an example of how cloud service providers are building libraries and repositories of public data sets to make it easier to integrate these data sets into cloud application. To me, that's a really clear sign of success. And so we're continuing that effort today. We have more than 130 public ML-ready data sets available, both in BigQuery and in Google Cloud Storage. And we hear from public data providers that they're really interested in collaborating with us. I mentioned earlier that this kind of feedback we get from our users is a sign of success for us. But another sign for me is that the providers of these really valuable data assets are interested in working with us and see us as a valuable opportunity to amplify their availability of valuable public data. As they would say in the 1984 hit movie, this is Spinal Tap, we're helping turn their offerings up to 11. I know it's a stretch to call Spinal Tap a hit movie, but it's a hit in my heart. We believe that we can work with our providers and be excited for us to work together to help them advance their goals and their efforts. And the fact that they see us as that kind of collaborative partner that they can work with, I think is a really great sign for us as well. But I think that the most important sign of success is our usage metrics. And these are kind of very high-level, aggregated measurements of how much data and how often it's being used. To me, that is the fundamental clear signal that we're doing what we set out to do, that we're making lives easier for our users. And I gotta admit, we're pretty encouraged. There are 780 petabytes of volumes of data that have been scanned since 2016 from BigQuery public data sets. And these are a representation that our users are leveraging public data sets to make their workflows easier, to get to the fun part of data science, the analysis. The number of data sets with more than 1 petabyte scanned per month have quadrupled since last year, which is July. Now, to give you some context, because I know 774 petabytes is this outrageously large number, it is roughly equivalent to the number of movies it would take to stock 4,500 Blockbuster stores. And side benefit, you don't have to rewind public data sets as a courtesy to the next user. 4,500 stores would have been about half of Blockbuster's nationwide reach during their peak. This is also equivalent to 541 billion floppy disks. And I recognize that floppy disks might not be the most effective or efficient medium for storing data today. As someone who has lost multiple papers that were stored on floppy disks, I understand. But that means that it's roughly 267 billion copies of the classic Oregon Trail game, which was printed on 2 3.5-inch floppy disks in 1982. It's also enough to fill the nearby Oracle Park, where the Giants play, nearly 300,000 times. The long and short of this is that that's a lot of data that people are using from the public data sets. There were more than 6,000 queries a day last month alone. And that means that just in March of 2019, our users ran nearly 2 million queries that use public data sets. And this number has continued to grow as well. The number of queries per day has grown by 18 times since next last year. And we're on pace for about 4x growth for the year in usage of public data sets. We're continuing to grow, and these key metrics are continuing to grow. I mentioned earlier that the number of petabytes, the number of data sets with at least a petabyte scanned has quadrupled. Data sets with more than 100 projects has tripled since Next, and data sets with more than 100 users have increased by 5 times since Next of last year. So all this is a really fun way to say that the program is really growing, and we're taking that as a sign that our users are encouraged by what we're doing. And I think one of the things we can do to continue to meet that need of our users is to support geospatial analysis and support the work that our users are doing with BigQuery's GIS capabilities. We provide more than 10 data sets right now that provide the polygons that define either political, statistical, or geographic boundaries in the US. So this is things like counties and states. This is things like the US coastline. It's things like zip codes and metropolitan statistical areas. Coming soon to a public data sets program near you, census tracts as well. And it enables you to easily join public data sets with other data sets for massive queries in minimal time. Things like NOAA's historical weather and storm data, MaxMind's Geolite 2 IP geolocation database, 311 bike share and taxi data from cities across the globe, and potential solar energy that's available by zip code. Or using your private data, as we'll see here in a few minutes, you can use public data sets and join public data sets to more quickly build dashboards and have a faster reporting environment for you to share the key insights. To support things like retail use cases and the impact of weather on sales. Things like how to better understand your target demographics. Things like conducting a competitive analysis using the SEC's quarterly financial reports, training machine learning models, and on and on. And the final one is being able to quickly and easily create visualizations that can help you communicate the impact of your story and understand what's happening here. This image on the far right is a map of the state of Ohio, and it shows lightning strikes across the state of Ohio for 2018 by day. And you can see that the dark green at the bottom, which represents kind of a higher number of lightning strikes, really stands out. And so this really helps you communicate that message really quickly and really easily. Now, I could stand here all day and talk about the Cloud Public Datasets program. Quite frankly, last year I did. But that's because I'm truly passionate about it. This is really what I love. But I think you folks would much rather hear it from the people who can best highlight how to use these data sets and how they can work with things like BigQuery's geospatial analysis capabilities or the ML-ready public data sets we have. And so with that, I'd like to introduce developer advocate extraordinaire here at Google, Felipe Hoffa. It's always a pleasure to work with Felipe, and I'm really excited for him to show you what he has.
Thank you, Shane. And thank you for all the data. Now give me a clicker. Give me a clicker, please. Shane. Clicker. Thank you very much. Thank you. I'm Felipe Hoffa, Google Cloud Developer Advocate. I love having a clicker to show the slides that I have prepared. I also love data. I love analyzing data. And for this public data talk, I want to use some of my private data. So since 2012, I've been recording everywhere I've been, almost minute by minute, and I have that data in BigQuery in a private data set. So now I can analyze it. So this is a table that shows everywhere I've been. Just I have the day, the time, I deleted the time from this version of the table, but I have it point by point, and I constructed a BigQuery GIS point for each of these places. And now I can map, I can visualize all of these points. If you were to analyze my life, the place I've been the most times in is my house. The second place I've been the most in is the office. And guess what's the third place I've spent the most time in? The bar is one. That's like the fifth. The third is the airport, and the SFO airport. And the rest of the time, this is everywhere I've been since 2012. Yeah, I've been traveling a lot. But these are only points in the map. I would love to enrich them, give them more meaning, know exactly where I've been, what cities, what countries, what continents. And now with the public, I can find public data sets that have some of that data. For example, GeoLite 2, MaxMind publishes a database that allows you to geolocate IP addresses. And we have a copy of this database in BigQuery, thanks to Shane. And I can not only find IP addresses here, I can find a list of cities. And I can find also what are the most important cities just by looking at how many IP addresses each city has mapped into it. And I took this table, I reduced it to only the cities I'm interested in, and now I can do a join between my points and wherever the cities are located, and then for each point I can find the closest city. Now, how do you do that? You could ask Stack Overflow how to do that. In fact, I asked the question, and then I replied to my own question, and that's yes, I didn't give enough time to anyone else to answer it. Sorry, Michael. Michael is one of our top Stack Overflow answerers, he's from the community. And he's here, so I'm super excited to have him here. But this is my query, and it works really, really fast. Once you have your points encoded as GIS points, BigQuery is able to quickly scan and index, go through this data. So with this query, I can just find everywhere I've been, and I can visualize it. This is the results of the query. Then I can, for example, move this data into Data Studio, and this is an analysis of how much time I've spent outside of San Francisco, in North America, Europe, Asia, South America. You can find every country. And I love doing this. Now, what else? In what other ways can I enrich this data? I could also find what's the weather been like for me. So have I been to hot places, cold places? Well, thanks to NOAA, we also have the daily weather in BigQuery. And instead of finding the closest city, I can find the closest weather station. Basically, I can run the same job. Now with the GSO OD table, I also transform this table to make the latitude and longitude into a native BigQuery type. I run the same query. And what you can see here is for each of my days, what was the temperature, and in each different color, in which country I was at that time. So you can see, for example, when the line breaks is, for example, I was in summer here, and I went to Chile in winter, so there is a big jump. Or you can see all of my Christmas, if I spent it either in 2014, I was in Egypt, that was pretty hot. Then in 2015, I went back home in Chile, that was hot too, summer in Christmas, then a cold Christmas in San Francisco, and then I had a very cold Christmas in Japan. And I can find and map all of this data very, very easily just with BigQuery and enrich my data with the public datasets. Now, I have a lot of friends that live in Seattle, and they tell me to not move there because it's always raining. That's not my experience, and I just want to prove it. Basically, I can find out every time I've been in the Washington state, and I can measure how much rain I have seen. Here you can see that I've seen cold days, I've seen hot days, but I have never seen 1 millimeter of rain. And I have the pictures to prove it. So, but my message is, take your own data, take your business data, take public data, and just enrich it, use our public data sets and all of our geo capabilities. And to see what people are doing at a larger scale, let me welcome back Shane.
Thank you. Can you give this to Claire? Can you give the mic to Claire? Yeah, thanks, Felipe. I'm actually a little flabbergasted that home was the top place you spent your time. I would have guessed San Francisco Airport, so at least I'm in the top 3. Felipe actually kicked around a few different options for demonstrations, and I'm willing to bet you'll see some of the alternatives in a future webinar. But we chose this demo because of how well it ties into our next story, where PushPay is using public data sets to better understand the lives of their customers. Which helps them determine how to focus their marketing efforts. And as someone married to a marketer, I can very, very sincerely appreciate the efforts to make any marketer's life easier. Now I'd like to welcome to the stage PushPay's Director of Marketing, Clare Hegg, to talk about how public data sets has helped them better subset for their potential user base.
Thank you, Shane. All right, Great. So I am going to talk about a little bit different topic on how this is helping us make some pretty sticky business decisions using the Public Datasets program. So first of all, I feel like I need to give you a little bit of context into who and what PushPay is. So we build mobile apps to connect community members outside of the traditional sort of Sunday, Monday, Tuesday type meetings that happen within churches and not-for-profits. We want to make sure, and just as importantly, that they also have a way to get payments and donations in a seamless pattern as well through this mobile application and as well as a web platform. So New Zealand is our founding place, but most of our customers are actually here in the States. So this is the perfect opportunity to kind of talk about how the situation looks for us here using public data sets in this country. So setting the stage, we have about 7,500 customers. We are about $25 million per quarter in revenue, and our annualized processing volume just reached about $5 billion. So when you look at the breakout of our revenue, we get about 30% of it from a SaaS fee, like a typical company, and then the other 70% actually comes from small transactional fees on that processing side with every gift that gets transacted. So when I arrived at PushPay, coming up for about a year ago now, it kind of struck me on how we segment our customers out. If you start to dive into the data, the gravity of this sort of breakout starts to mean something to you. So traditionally, it was pretty incongruent with the way that we actually did our sales process. So it's looking at our customers sized by their weekly attendance. So in a church, it's a pretty hard number to try and get, one thing that our platform helps them do. So most of our customers are giving us a self-regulated, generalized ballpark of a number. And then when you look at where the majority of our revenue actually comes from is the processing side, and most of them either have a very indiscriminate number of what they think their revenue actually is. Churches don't typically think in revenue numbers. It's not where they place their time and thought. And so when we were founded, and we're a fairly young company at the end of the day, this looked like a really simple solution to a very simple problem. Our customers give us a self-reported number, whatever number that is, we have a baseline of what we're going to charge them for that monthly SaaS fee, and then processing fees are all standard. So as a product marketer, I wanted to reassess our pricing model so that we could maybe do something a little bit more like a monthly active user model because we are a mobile application. And in doing so, I realized quite quickly that we didn't have accurate data in any way, shape, or form, either on the number of members that were in the churches or the processing volume that was going through individually. So fortunately for me, I moved to PushPay from a company called Socrata, which was the pioneer in open data portals for the government, so where a lot of the public data sets actually come from through the Socrata API. So with this data, knowing that there was public data out there somewhere for me, I took to BigQuery and was able to find the IRS 990, which in layman's terms is basically all of the not-for-profit data revenue from the IRS put into BigQuery here. And then this was great. So now I knew the data existed. I had really easy access for it. So now I can actually start to test my hypothesis a little. So knowing that churches come in all shapes, sizes, colors, and flavors, this must mean, in my head, I'm thinking there must be differences in how churches give, how the members of those churches give. And so if 70% of our annualized revenue comes from these transactions processed through the platform, then budget is a really big factor when determining the lifetime value, segmentation, and ultimately the cost to the customer. So if this were, so this basically was, in my hypothesis was, how are we charging our customers? We're probably overcharging some of them, undercharging others. And I wanted to make sure that we had a more stationed way to do that. And so through some great help from Shane. I'm smart in the ways that I'm smart, but I'm not a data scientist, but I didn't want to bother our data scientist team to go and make a bunch of queries and assumptions based on my tiny little thought that maybe this was the way that we could reprocess and resegment our market. And so while BigQuery gave me a really good opportunity to segment out the data and get the data to a point where I could extract it, I wanted to see it in a little more visual way. So what I loved about this is I could actually just take it into something that spoke my language as a marketer a little bit more and pull it into Data Studio. So the initial insights here, while it's exactly what I thought I was going to see, I was still a little bit shocked. So what you're looking at is that the bottom axis is the attendance of the entity, and then the top is the revenue. So there are actually a bunch of churches that have really small congregations, but very large donations, some of that due to maybe location because of high propensity towards giving or higher median income levels. So churches have a lot of other differences in what they do as well. We have Protestants, Catholics, Episcopalians. Each of them have a different view of stewardship and what it means to donate to your church versus what it means to give to maybe an associated school or another not-for-profit. So for example, we have one Protestant church in Arkansas that has 8,000 members, but barely breaks the $2 million donations per year mark. And we have an Episcopalian church in Seattle near another very big data school where they have about 800 members, but they're actually breaking over the 10 million mark. Part of that is due to median income levels, and part of that is just due to the differences in how fundamentally that denomination thinks about donations. So for me, the funny thing is you're at a geospatial talk, but the icing on the cake was actually the geographical side. So there were obvious geographical differences as well. This is all of the data based on location. One thing that you will note, there's a lot of dead space in here, and that's what we're going to be able to fill in with some of our data, because not every church is required to, in every state, is required to actually file for their 990. And so with that missing data, we'll be able to fill in again from sort of our set of data. But what this shows is where we have our sales territories might also be something that we need to consider changing, making sure that each and every one of our sales team members has the right capacity underneath them. And then, so for me right now, the next step is I'm going to add more public data, median income information, for instance, and then I'm going to actually look at setting up our team so they have equal opportunities depending on where they're at. And so net, the real work actually kind of now begins. I'm at the front stages of this, but I get to go back literally on Thursday. I have a meeting with our board of directors to talk about where we take this to the next level at the company. So I'll be sitting down with that team. I'm armed with actual data points that we can evaluate when making these big, broad, company-wide decisions before I go to my data science team and derail the work that they're already doing. I've actually kind of helped with part of that 80% through the use of BigQuery, and it was a pretty easy process for me. And so the thing that we're going to be able to do is actually resegment our prospect base so that our customers are segmented the right way, more on a per capita of budget dollar, rather than just a stained number of how many people come to the church on a weekly basis. We're going to be refreshing our pricing model through our platform. We're now able to look at the number of members that go through and actually use the platform, so we can actually have a more reasoned approach to how we're doing that SaaS fee. And then on top of that, we're going to be able to look at how we're structuring out our sales team so that from a territory perspective, I don't have one person who's unfortunately over in one of those dead zones that doesn't have a lot of high donating areas, so that from a processing side, they're getting the same amount of volume as we change the way that we do our quotas as well. And again, this is something that we're able to do incredibly easily just through this program. And then the ability for me to make these visualizations was 100% seamless. You just click a little button, and it was the easiest thing I've done all week. And so for the next step on my side, as I go back, I'm going to be looking for more data that exists in the program that I can pull in, and then take that back and have these conversations. So hopefully next year, if I get asked back to talk again, I'll be able to say, hey, this is what we actually were able to accomplish, and the more, so sort of the more data sets that we were able to pull in, I believe the more impact we're actually going to be able to have for our company.
Yeah, thanks, Claire. You touched on one thing that, the IRS 990 data set in particular, the way it's coded is kind of very specific, right? And you have to be able to go into the documentation and understand what these codes mean and what they are. And I think that's kind of one place where we work really hard to support data providers, is not just helping their data scale, but helping their expertise scale, and making sure that we do a really good job of explaining what the data are, what they mean, and what some potential limitations are as well. And we'll dig into that a little bit later. Claire and I were actually talking just before the session that she was telling me a story of some churches that were impacted by the campfire last year, and how PushPay and their kind of subscription to PushPay had helped kind of support neighboring churches that were impacted. And I think it's just such a natural connection to our next speaker, Kian, that tells such a really great story of how we can support folks that are impacted by natural disasters. I was actually here in San Francisco last year, the day that the campfire started, about 200 miles from here. And I distinctly remember how quickly the smoke blew into San Francisco, and just how thick the smoke was here, 200 miles away from the center of the fire. So I'm really excited to have MeiDai here. Their work is helping support first responders as they respond to natural disasters around the country. And I'd now like to welcome to their founder and CEO, Kian, to the stage.
Hi, everyone. I'm Kian Mirshahi, founder and CEO of MeiDai.ai. We are an artificial intelligence-enabled disaster information services platform providing real-time and near real-time services to first responders as well as residential and commercial subscribers. So I just want to spend some time dealing with, giving you some statistics before I get into some of our services. In the past 20 years, globally, there's been close to $1 trillion in damages from disasters. The United States takes the lead, going through about $1.5 billion in damages, followed by China and Japan. The most devastating, as you've probably experienced, are storms, followed by wildfires and flooding. In fact, over the past few years, the average damage caused by storms are close to $100 billion a year. Wildfires are close to $30 billion a year. And floods, half of Iowa is flooded as we speak, close to $20 billion per year. Just another depiction to show you how serious and severe these events are becoming in the United States alone. So this is a chart that's put together by NOAA. As you can see, in the 80s, so 20 years ago, you'd be dealing with a few billion-dollar related disasters, causing about 60 or 50 billion in damages. Look at the exponential growth all the way to 2017. You're looking at dozens, maybe even more, causing some 360 billion a year. So 2017 was actually a record year, 360 billion, not just for the United States, but globally, followed by 2018, Florence, car fire, the red tide in Florida, and 2019 is already the wettest year on record. So what used to be kind of seasonal and predictable is shifting to become a lot more unpredictable and random. So For wildfires, for example, you could almost set your watch to it. When it came May, you could see some fires starting to appear, and then by October, you could say you can start your Christmas vacation if you're a firefighter. Thomas fire was in, Carr fire, was in November. The Thomas fire was in December. So you can see how anytime, almost 9-10 months of the year, we could have wildfires here. So almost 70% of the country is exposed to these events. As you've experienced, they're becoming more severe. They're expanding larger and larger wildland and urban areas, creating a need for us to think about how we manage disasters differently. So obviously, being reactive to these means billions of dollars more. Being proactive means possibly getting to these sooner and look at ways and means that we could reduce these damages substantially. So yes, these events are extremely challenging, but there are some systemic challenges with disaster management that make this even more challenging, if you believe. So amplified by so many factors. And this isn't just unique to the United States. This is a global problem. So from a tech perspective, you're dealing with platforms that are highly decentralized. They don't communicate with each other. There are limits from an infrastructure perspective. So if there's any damage done to an infrastructure during a disaster, you can't access critical information. From a process perspective, you can't really have a standard process for a lot of these events, different jurisdictions, different territories. And then you deal with the politics of information sharing. The simple fact of who gets credit, who gets blamed, can mean how quickly information goes from a national level organization down to a city level or vice versa. Resources, well, you can never really train folks enough to handle some of these events. And from a general public perspective, folks are rarely informed in a timely fashion. So the notion of getting real-time information does not exist today for a lot of these disasters. And of course, the first responders are always trained. So about a year ago, I founded this company to ensure that we can try at least, handle some of these challenges, but at the same time, democratize, pertinent disaster information when it's needed most. What I'm proud to tell you today is that we've built a platform with MeiDai that allows for centralized and a cloud-based, or essentially microservices and cloud-based platform that makes the ease of integration and users this platform fairly easy. It allows for event-centric communications. So you're probably used to getting Amber Alerts. This is more event-centric to first responders and folks who are affected, whether it's an individual or a group, based on a selected area or a radius. And it's highly, highly affordable. So in sum, this is what our ecosystem kind of looks like. We cater to residential, commercial, and governmental customers, catering to iOS, Android, and Microsoft, various devices, as you probably know, using various data sources. So the Google Cloud program and the big data program is a big part of our training and learning. We've used this in many scenarios, and it continues to be a big part of that. We use geostationary and orbital satellites, as well as drones, sensors, and social media sentiment analysis to create real-time and real-time information services covering the disasters that are highlighted below. So, campfire. This is just before the sunrise that we detected this event, almost a couple of minutes after it occurred. So this essentially makes us one of the fastest platforms in the world. The yellow boxes show potential hotspots. The red boxes are confirmed events. And the green boxes are false positive or events that have ended. So why does it matter to be notified a minute earlier? Well, the campfire was burning 100 or so houses a minute. What if you had 30 minutes more to prepare? How much of a difference would that make to your life? So it's key to have information when it's needed most so you can handle an event like this or many more events like this. And as Shane was alluding to earlier, you can kind of see the smoke pattern after this event. So that's the pollution or the level of carcinogens that we deal with after a wildfire. We're actually introducing a product that deals with pollution, air pollution, real-time particles with AI that we'll be introducing. But essentially, this is a quick demo of what we've been able to successfully conduct with the Big Data program. So from a timeline perspective, we're very excited to be launching this platform in Southern California. We'll be working with MetroNet, launching with 8 cities out of OC officially in May, and we'll be expanding this to the rest of California in June. Wildfire awareness is a big part of our campaign. We want to continue to educate and re-educate folks through universities and educational institutes. The app is free for students, and it's $1.99 per family, or 99 cents per person per year. So highly affordable. We'll be launching the fire products to begin with, including drone services for reconnaissance and for delivery. In Q3, we'll be introducing a whole host of new products, including IP 911, active shooter and terrorist attacks. Q4 will be larger expansions of our products with some European and APAC expansions. And 2020, it's our global expansion to a whole host of platforms in Europe, as well as other disaster prevention mechanisms that we'll be using. With that being said, I want to thank the Google Cloud and the Big Data program and how crucial they've been to this campaign, and we're really excited to launch this product.
Thanks, Kian. This is a really powerful capability that y'all are working on, and we're really proud to be able to support your efforts to enhance the impact of first responders and emergency managers as they respond to these natural disasters. So we've seen 3 really powerful demonstrations of how Google Cloud public data sets can support your geospatial analysis for just about any use case. You saw a demo from Felipe to help understand how the world around you impacts your life. We heard from Clare about how public data sets can help you make more efficient, data-driven business decisions. And Kian just demonstrated how public data sets are helping MeiDai support the community around them. So obviously now you're all very excited about public data sets. What can you do next? Which is a really probably overused Google Cloud next pun. So let's start with what you can do this week. The week is young. There's still a lot going on. The first thing you can do is stop by the BigQuery booth. Either tomorrow or Thursday, I'll be at the BigQuery booth myself, and I would love to talk to you about public data sets. Any questions you have, any suggestions you have, I'd love to hear from you. The other thing you can do is check out more of the sessions that feature or talk about public data sets at Next. There's a couple on here I really want to call out in particular. One of them being the Kaggle session. That's hosted by Anthony Goldblum, the CEO of Kaggle. But he is also going to be talking about the Kaggle Public Datasets program, a group with whom I work very closely to kind of coordinate our efforts. There's also some hands-on labs going on throughout the week, including predicting visitor purchases using BQML, and data visualization with Google Maps and BigQuery. So those are kind of going on at any time, but there will be some people around that can help answer questions and kind of troubleshoot some challenges you might have. And if you want to learn more about Data Studio or BigQuery GIS, check out these sessions, including the planet-scale geospatial processing, which will have, if I remember correctly, it has the group from Global Fishing Watch, which is helping fight in slavery and other issues that are kind of troublesome in the fishing industry. And then make sure you come out to the developer keynote. Come see Felipe again. Come see all the amazing speakers we have lined up, and they're going to talk about getting to the fun part, which is what public data sets is really trying to do, is help you get to the fun part. I have yet to meet a data scientist that says that data cleaning and prep is the fun part for them. If that's you, I'll be at the BigQuery booth tomorrow. I would love to hear from you. But I think that most of us want to get to the analysis and want to get to the insights from our data. And so that's a really great way to get you really excited about public data sets and ready to start doing. And what can you do after this week? Well, first thing you can do is explore our public data set catalog. You can go to GCP Marketplace, and you can find our catalog of data sets. And each of these individual pages in here provide you more details about the data set, including who the provider is, If there are any kind of known issues with cleanliness that need to be addressed before you analyze it, if there are any kind of known things like we mentioned with Clare, the 990 data set earlier, with translating codes into kind of meaningful outcomes. We also talk about refresh rate of each of these data sets. It's driven by kind of when the best time to do that for the data set is, but that's also listed here as well. So this is a great place, a great first stop to go to figure out what we have available. And the other thing you can do is learn more. I will be hosting a Cloud On Air webinar on Monday, April 29th, talking about GIS work and using public data sets. I kind of teased earlier that we're going to do some stuff with some demos that Felipe wasn't able to get to and use, and I think this is going to be a great place to see those. So thank you so much for coming out. I was worried we weren't going to get over like 25% of the room full, and it is packed, and I love it. And enjoy the rest of your week.